Applications with ratios and proportions. On the test, ratios and proportions and word problems that utilize that information, there's quite a few. I would say you probably maybe see 2 or 3, actually. That's quite a few. So they are pretty common. Also, you don't really need to know anything special in order to solve them. You just utilize the information that's given to compute. Now, look at this first example here with Lisa. It says Lisa gets 120 miles on 4 gallons of gas. They want to know how far she could go with 7. So a couple of things to think about, okay? I always tell students, like, hey, 120 miles on 4 gallons of gas. So what do you think about 7? Do you think she's going to get more miles? Hopefully your answer will be, yeah, she's definitely going to get more because you're putting more gas in the car. And then I ask them another question. I say, well, is that answer going to be double instead of 120? Can she get 240 miles? And students might say, no, I don't think so there. And I'll say, well, why? I'll say, well, if she got only 4 gallons of gas, if you double that to 8, that would give you 240. But she's only going to 7, so she's not going to double that. And I'm like, yeah, that's good thinking. And I'll say, well, at 7 gallons, is it going to be close? Will the answer be close to 240? I'm going to say, yeah, it'll be close to 240, but it won't be 240. It's going to be less than 240. And I'll say, hey, great job. That's how I always tell students to approach their math. Instead of thinking about what the answer is, being so focused on what this answer is, kind of just ask yourself a few questions about things. Think about the information that's given. Think about what's being told to you. And then hopefully with that kind of information, as you start to work through the math problem and an answer comes out, then you can say, well, is that answer reasonable to something that I was thinking about? Yeah, sure was. So check this out. What you had to do is you notice that you take 120 and divide it by 4. You do that because you want to find out how many miles she's getting for each gallon of gas. So 120 miles divided by 4 gallons tells me that she gets 30 miles for every 1 gallon of gas. So this is called a rate. Also, you'll see it again later as a unit rate. Unit means for every one, how do I get? So you say for every 1 gallon, I get 30 miles. Now, with that information, you can just now multiply it by 7 and say, well, 7 gallons times 30 miles, well, that's going to give me 210 gallons. So let's give this a shot. Let's try it out. Look at number 1. Billy plays baseball and has a hit-to-strike ratio of 3-2. If he has had 50 strikeouts this season, how many hits has he had? So again, I always tell students, again, approach the information logically. So for instance, if it's hit to strikeout, it means that this first number is the hits. The second number is the strikeouts. So I'll always ask students, like, does he get more hits or more strikeouts? And students will usually tell me, well, if it's 3-2 and the 3's the hits, well, that's more than 2. And I'll say, yeah, that's exactly right. And he's going to hit more than he strikes out. So I'll ask them, well, what do you think about 50 strikeouts? And I'll say, if he's gotten 50 strikeouts already, should he have hit the ball more? And they'll say, yeah, he should have hit the ball more. I'll say, yeah, so that number should be more than 50, right? I'm like, yeah, he should have hit more. So I say, well, let's put some information together then. Let's figure out how we can do this mathematically. So there's different ways to do this. I don't really like to show the math. I like students to come up with their own ideas, but I will throw some ideas out. For instance, there's something interesting about this. So when you have 3-2, when you're given this 2 pieces of information, that's not a total. What it is it's a hit and a strikeout. So the thing is this, you have 3 hits, 2 strikeouts. There's another number that you can generate from these two things, and the number is 5. Let me show you why. What it says is, if I, for a total of 5 times Jimmy or Billy goes up to hit, let's say he goes up to hit 5 times. Well, 3 of those times he'll get a hit, and 2 of those times he's going to get a strikeout. So you can think about it like, for every 5 times Jimmy goes up, or sorry, I want to say Jimmy. For every 5 times that Billy goes up to hit, he's going to get 3 hits and 2 strikeouts. So with that information, what would you do with this? So if you know he's going up to, he's gotten 50 strikeouts, how many hits does that generate? Now, I don't really like to show the math. I would like students to come up with their own ideas. But I do want to, like I said, point out a few different pieces of information that you can use. So give this a shot, see how you do.